Our topic for this afternoon is laws of exponents, or in other books, this is also called the law of indices. Alright, so these are the basic parts of this. Okay, let us try to determine what are the basic parts. So when we say power, alright, it includes all the 5 and the 3 there, alright? But the 5 there is termed as base, and the 3 is called the exponent, alright? So let's say, for example, we can have it as 125 is equal to 5 cubed, or 5 to the power of 3, which means that the exponential form of 125 is 5 cubed, or 5 to the third power. Alright, so 5 cubed, it also means that we have 3 factors of 5, which means we have it as 5 times 5 times 5. Okay, now number one, the first law of exponent. um, in the exponential form, okay, when we say that it is x to the power of n, it only means that we are multiplying x to itself n times. Okay, n times. That is why we have n, x times x times x, until x. We don't know how many x is that, so that is n. Okay, so n factors of x. So just like in our example in the earlier slide, we had it in 5 cubed, which means we are going to multiply 5 by itself 3 times. Okay, so 5 times 5 times 5. Next, multiplying powers. That is our second rule, which means if we are going to multiply powers with the same base, okay, remember, same base, we just need to keep the base and add the exponents. Let's say, for example, we have x to the power of m multiplied by x to the power of n. As you can see, they have the same base as x. So what we are going to do is we are going to copy their bases, since they have the same base, and we are going to add their exponent, which is m plus n. All right, so let's say, for example, we have 2 to the power of 6 times 2 cubed, which means we're going to copy the base, which is 2, and we're going to have the exponents as 6 plus 3. We're going to add the exponent. Okay, which means we have 2 to the power of 9, or that is simply 512. Okay, that is the second law. Yeah, you're right. So when we multiply powers, we are going to add the exponent, okay, if they have the same base. The third law is dividing powers. When we try to divide the powers with the same base, okay, same base, we're going to keep the base and we're going to subtract the exponents. So if you have remembered in our earlier slide, if they have the same base and we're going to multiply those, we're going to add the exponent. But in this law, if we're going to divide it with the same base, all right, we're going to subtract the exponent. Okay, so if we have x to the power of m over x to the n, then we are going to have it as x, copy the base, and we are going to have it as m minus n, or the exponent of the numerator subtracted to the exponent of the denominator. Right, so if we have 2 to the power of 6 divided by 2 squared, then we can simply express it as 2 to the power of 6 minus 2. All right, which means that is 2 to the power of 4. All right, yeah, you're right. So when you divide powers, okay, when we say powers, that includes the base and the exponents. Okay, when you divide the powers, we simply subtract the exponents if they have the same base. All right, so try this one. 3 squared times 3 squared. I'll give you 5 seconds to figure this one out. Okay, so what are we going to do with that? 5, 4, 3, 2, 1. All right. Number 2, 5 squared times 5 to the fourth. How about number 3? A to the 5 times a squared. How about number 4? 2s squared times 4s to the 7th power. How about number 5? Negative 3 squared times negative 3 cubed. And how about number 6? S squared t to the 4th times s 7th t cubed. Okay, very good. I know you are very good with this, so let's try this. 7, 8, 9, 10. You can also try that one. You can actually pause this video and try to figure this one out by yourself. So in this, let us try to check it out if you're right. So for number 1, the answer would be 81. That would be 3 to the power of 4. And for the number 2, that will be 5 to the power of 2 plus 4, or 5 to the power of 6. And number 3, that will be a to the power of 7, 4, 8s to the 9, 5, negative 243. Alright. Number 6, that would be s to the 9, t to the 7th. Number 7, that would be simply s to the power of 8. Number 8, we simply have 3 to the power of 4. Number 9, that would be s to the 8th, t to the 4th. And number 10, that would be 9ab cubed. Alright, so I hope you got the correct answer. The next law is what we call as the power of a power. So if we are going to raise a power to an exponent, then what we need to do is we simply multiply the exponents. Alright, so let's say for example, we have this, or the general rule would be like, when we have x to the m to the power of n, we just need to multiply these exponents. That would be x to the power of m times n. Alright, so if we have 5 cubed to the power of 2, then we simply have 5 to the power of 3 times 2. Alright, so that should have been 6. That not 5. That should have been 6. Alright, so when we try to take a power to a power, we simply multiply these exponents. Alright, the fifth law. So we also call this as the product law of exponents. So if the product of the bases is powered by the same exponent, right, then the result is a multiplication of individual factors of the product, each powered by the given exponent. So simply like this, xy, okay, and we have a parenthesis to the power of n, which means this n here, all right, we these x and y possesses the same n. Okay, they possess the same exponent, which is n. So we have it as x to the n times y to the n. Okay, since they have the same exponent. But okay, remember, this is only applicable for product. Okay, as you can see, this is a product here, x times y. This is not applicable to the other operations like the addition, the subtraction. No, this is only applicable for the product. Okay, let's say for example we have ab squared. Okay, we have a parenthesis, so take note of this parenthesis here. Okay, because if it does not have any parenthesis, then it would just be xy to the power of n. Then it only means that this n here belongs to y only, not to x. Okay, but if we're going to put a parenthesis there, it means that the n there is for both x and y. Alright, very good. Next, number 6, the quotient law. So we're done with the product law. Now, let's proceed with the quotient law. So this is actually similar with the product law. If we have a quotient, okay, of the bases and it has the same exponent, then the result is both the numerator and denominator each will be given with the same exponent. Okay, so if we have parenthesis x over y to the power of n, then it only means that it is x to the n over y to the n. Okay, you can also it have as vice versa. when we have x to the n over y to the n, then it can also be expressed as x over y to the power of n. Don't forget the parentheses. Okay, so for example, we have 2 over 3 parentheses to the power of 4. Then we can have it as 2 to the power of 4 over 3 to the power of 4. Okay, which is simply 16 over 81. You can also simplify that one if you want to. Okay, you can also take time to pause this video, all right, and try to answer this by yourself. Okay, so if you are done, then let us check it out if you're right. So for number 1, that is 3 to the power of 10. For number 2, 8, 12. For number 3, 8a to the power of 6. For number 4, that is 16a to the 10, b6. For number 5, that would be 9a to the 4. For number 6, that is s6p to the power of 12. Number 7, that is simply s to the 5 over t5. Number 8, that is 3 to the power of 8. For number 9, that is s squared p to the power of 8 over r squared. And for number 10, that is 81 a squared p to the power of 6. All right. Number 7, the negative law. So if the base is powered by a negative exponent, then the base becomes reciprocal with a positive exponent. Okay, so this is one of the most trickiest part upon among these laws, because this is quite tricky. You need to remember this reciprocal term or the multiplicative inverse of a certain term. So remember that negative exponent is not allowed in algebra, all right, in any field of mathematics so far. Negative exponent is not allowed. That is why we need to express it in terms of its reciprocal. So the reciprocal of x, um, okay, so let's have it like here. So the reciprocal of a, we have an example here, is 1 over a, right? Okay, and if we have it as a squared, the reciprocal of a squared is 1 over a squared. Okay, that is the reciprocal. Now, it says that if we have a negative exponent there, then we just need to take its reciprocal and the exponent will become positive, which means if we have it as x to the negative 4, we will have it as 1 over x to the power of 4. All right? All right. Okay. So another example for that one is when we have a 5 to the power of negative 3, then it will be 1 over 5 cubed. Okay? And on the other hand, if we also have 1 over 3 to the power of negative 2, then the reciprocal of 1 over 3 to the negative 2 is 3 squared. That is simply 9. Okay? Next, zero law of exponents. So any base powered by 0 exponent is equal to 1, which means any base which has a 0 exponent is equal to 1 except by 0 itself. Okay? Any number, we can substitute it with x except for the 0 itself, because 0 to the power of 0 cannot be equal to 1. Okay, so you just simply need to remember that one. Okay, because if you're going to ask me why did it become 1, okay, let's try this. 2 2 2 2. Okay, so 0 1, these are exponents, all right? Okay, okay, so 2 squared, that is equal to 4, right? Okay, let's try to extend that one. So 2 cubed, 2 times 2 times 2, that is equal to 8. And 2 to the power of 1, that is 2. 2 to the negative 1, that is 1 half. 2 to the negative 2, that is 1/4. And 2 to the power of negative 3, that is 1/8. Okay, so as you can see, 8, 4, 2, we can see a distinct pattern right there. Okay, so if we're going to start at the top, you can see like it is a multiple, or it is being divided by 2. 8 divided by 2, that is 4, divided by 2, that is 2. Okay, divided by 2, that is now 1. Okay, divided by 2, that is 1/2, and so on up until we come up with 1/8. So it is still the same if we will start at the bottom, 1/8 to 1/4. How can we, what is the behavior of the numbers there? So from 1/8 to move to 1/4, we can simply multiply it by 2. So 1/8 times 2, that is 1/4, times 2, 1/2, times 2, that is 1. And that is not 0. Okay, so that is simply the logic right there. Which means 5 to the power of 0, 8 to the power of 0, everything that has an exponent of 0 except 0 itself, that is equal to 1. Alright, so you can also try this one. Okay, so you can try to take a pause like right now, try to answer it by yourself. And here are the solutions for these sheets. Okay, up until to number 10. Okay, I hope you got it right. So that's it. Goodbye.